Dr. Mae Jemison. So let's get everything started with a really simple question. How many people here have been to outer space?
Well, Mike just left.
Yeah, he's in the back. Anybody on the sides? Nobody? Oh, you have. Good.
But Mike just left, but I
Yes.
want us all to know we're in space right now. Right? Because I can tell you, and Mike can tell you, that when you look out, when you're in the shuttle and you're looking at the Earth, you recognize it's in space. And we are the aliens for someone else. Right? So we've been there, and I want to just say that it's my pleasure to be here today. Mike is an incredible astronaut, and Sunita Williams was here as well, who is also an astronaut. She's flown multiple times and will also be one of the first commercial astronauts. So we've had a number of people who've been to outer space, but we're all in space right now.
It's exciting. I'm not an astronaut. I'm just more of a space cadet, actually. But I'm happy to be here and talk to you. So you've had a wild, crazy ride your whole life. Mike covered some of it. Let's start at the beginning. You were born in Alabama and then grew up on the south side of Chicago.
Yes, and I always tell people that, you know, what you do in life and who you are very much is based on your experiences and what you've seen, what you've been involved in. And I did something really good very early in life. I chose my parents well. Didn't do as great a job with my siblings, but they're pretty good too. Ooh, no, I'm the third of three. I'm the third of three children, which actually is pretty good because being the youngest child meant that I had to learn how to adapt to older siblings and had to learn to get through even as they treated you as the youngest sibling. So anybody here who's a younger kid, like who had older brothers and sisters, you know what I'm talking about, right? Where you had to learn how to protect your candy and all of those kind of things, right? So those were really good things. Growing up in Chicago, I went to Chicago public schools, and I loved museums. I would always go to places like the Museum of Science and Industry, the Art Museum, the Field Museum, the Planetarium, the Aquarium, and they were really important to me because they were about learning the greater world. And what did I love? Why did I love that? Because it was about exploration and creativity, right? Exploration and creativity. So when Mike said that I loved dance and science, it was really about creativity. And I loved art and all kinds of things. I just wanted to know what was going on in the world.
Well, you, from a very early age, you had a pretty good sense of what direction you might be headed in. When your kindergarten teacher asked you, as they ask so many kids, what you wanted to be when you grew up, what did you say?
I said, I want to be a scientist. And this was about five years old. And all the kids were raising their hand and different people had different answers. And when I said, I want to be a scientist, she looked at me and she said, don't you mean a nurse? Now, I had no problem with being a nurse, but that's not what I intended on being. So I put my hands on my hip. Okay, imagine 5 years old, put my hands on my hip. And I said, no, I mean a scientist. And I was really kind of bothered that she was going to correct me. But the reality was she was trying to help me manage my expectations. What could a little girl on the south side of Chicago expect to do in the 1960s in science, be a nurse? But that's not where I was going. I was very interested in science because of that exploration and creativity. And so that's one of the things I went ahead and did that. And I always was involved in lots of things.
And scientists are, of course, exploring and examining everything. And so naturally, one of the things you first were fascinated by was pus. It's right here. I got it. It says pus.
Yeah,
right?
I liked pus, I'll confess. I still like pus. I'll tell you the story. Here's the story. And it's hanging around the internet, but this is a true story. When I was, again, at 5, 6, 7 years old, that's like a really good time because you like different things, right? And you haven't learned that you're not supposed to admit stuff yet. And so I love sores and scabs and all of that. It was fascinating because this is something your body did, right? You didn't have to do anything. This is something your body did. And so one time I got a splinter into beneath my thumb, and we got it out, but a little bit later, my thumb swelled up. So I'm like fascinated because my thumb is swollen. It's like, what's going on there? And then I hit it, and this stuff came out. And I didn't say yuck. I was like, wow, what's that? Right? And I went and asked my mother, and she told me it was pus, and then I'm like, well, what is it? And she said, well, first of all, she made me look stuff up because luckily I could read really well. But she made me look things up, and she said it's your antibodies, your white blood cells, like fighting bacteria and infection. And I thought, is this the neatest thing in the world? That your own body could fight infections. It created things to fight infection. And so that's been a love affair that I've had ever since then, that my own body can do that. So I love parasites and bacteria, infectious diseases, because just think about it. Right now, your body is protecting you against all the other organisms that are around. Every day it does that. That's pretty neat.
Yeah.
That's really cool.
And I think I can speak for everybody here to say that I think everybody has a love affair with infectious diseases and parasites. I think I'm right. Is that what everybody's thinking? You mentioned growing up in the 60s. Do you remember seeing the moon landing? How old were you? And do you,
I remember seeing the moon landing. I remember being awakened, to make sure that I watched it when they were actually coming out, because after they landed, they had to do a bunch of things first before they came out. But my fascination with space predated that. There's an African proverb that says, no one shows a child the sky. And I remember as a little girl, yes, I looked at the clouds. From when I remember, you remember looking up at the clouds and wondering what they were, coming up with ideas, looking at the stars, always imagining being there. And I followed the space program. So I had the set of books that talked about what was going to happen in space all along and how we were going to get to the moon. And I would run around Chicago quoting to people why it was important that we were going into space and that I wanted to be a part of it. But I remember the moon landing. I remember that it was like, of course we did it. It wasn't, I know adults were thinking, this is amazing. But at that time, I was thinking, of course, everything is possible, right? And as a little girl growing up, even though there were no women astronauts, I assumed that I would go into space. I didn't assume that I didn't want to be an astronaut. I assumed by the time that I got old enough, there'd be lots of people in space.
Did you ever feel like because you were a little girl that actually was not possible for you?
So growing up, I was just irritated, right? I thought that it was the dumbest thing in the world that we didn't have women astronauts. And even when people would try to explain to me, to help me understand, I did not believe it. Not at all. And the reason why was, first of all, Valentina Tereshkova had gone up in 1963 with the Russians. So I knew that. And then I also remembered that there were these women who had been tested for the space program. And they should have gone. And then I knew that I had enough energy and courage and strength and everything to go up. So there was no way anyone could explain to me why that was happening. But it didn't discourage me. I just figured out the world was going to change. Right? Not me. I wasn't going to change. I was going to go up. But we would get there, and we have. And there's a lot that we can look at, and knowing that women have been involved in so many things throughout the years. And you'll find in the HoloLens experience, we actually talk about women who have been involved all the way from the people who did the computations for astronomy in the 1900s, all the way to the woman who has the person who has the most hours of any American astronaut in space is a woman, Peggy Whitson. So we've been there, and we're constantly there, and we're going to continue to be there.
And what she's referring to is the Microsoft HoloLens experience that we've partnered with Microsoft on, and that all of you will be able to go do. It's up on the flight deck. We're going to give you a sneak preview of it a little bit later. But it wasn't always a sure thing that you would become an astronaut, let alone a famous astronaut. You were pulled in at least one other direction. If you hadn't become a famous astronaut, what do you think you might have done professionally?
Well, I didn't care whether I was a famous astronaut or not. I wanted to go into space. There's a difference, right? I'm not playing semantics. Because again, by the time I thought I was going to be old enough to go into space, I thought there'd been all kinds of people, all sorts, and I would just be going there as a job. I always knew I was going to go into science, so I would have gone into science one way or the other, no matter what. But I also love dance. So all the way through from grade school to high school through college, I was always involved in dance. I was involved in performing arts. I did ink block and drawings, all this kind of thing. My senior year in in college, saw me trying to decide between coming to New York City to be a doctor or to try to become a professional dancer. And my mother helped me solve that. She said, you can always doctor if you're a dancer, but you can't necessarily you can't necessarily doctor if you're a dancer. So when I came to New York and I went to medical school, East 69th Street, over there, Cornell, New York Hospital, Sloan Kettering, right there, I would spend all of them, if I had any money, medical students don't have a lot of money, if I had any money and time, it all went to taking classes at Alvin Ailey. And I used to do it all the time. It was fabulous. And in fact, I took an Alvin Ailey poster up in space with me of Judith Jamison performing the dance Cry. I love dance.
That's awesome. And you were, because a lot of medical students have a lot of free time. So let me get this straight. You were actually dancing your way through medical school. Whenever I had time, I was going. And I used to take classes pretty much once a week and things like that. It helps keep your mind healthy. It keeps you focused and centered, right? Physical exercise is really important. Okay. All right. So you go to college. You finally get to college. Let's just go back to your undergrad days. You go to Stanford, and you were how old?
16.
16 at Stanford, which makes me so disappointed in my children. I'm going to have a stern talking to with them. So you're 16 at Stanford. Did you feel incredibly young? Did you feel like you didn't fit in? Were you nervous or worried about being accepted in the student body?
No, not at all. In fact, I was running things. No, I was remember I told you about that whole age order, is a great thing that I was the third child, so I had to learn how to take up for myself. And my sister was in the first class of women students at Wesleyan College, so I already knew about that. My brother had gone to college, so by the time I came around, it was just sort of okay. And I'd been student council president in my high school, so I was used to running things there. So when I got to Stanford, and because I was tall and nobody necessarily knew that I was 16, I really didn't worry about it. The folks in my dorm did, right? Because everybody knows everything about you. But I lived in a 4-class dorm, and so no, I didn't feel that way at all. And in fact, I didn't even realize it was even an issue or a consideration until much later, when I realized at 16 my parents had to have a lot of confidence in me. And that was back in the time where you didn't necessarily go to colleges before you go to visit them before you went to college. I know that sounds foreign to people right now.
So you just showed up.
You made your applications. Every application was done on paper. You guys won't believe this. Some of you really won't believe this. You used to have to write a separate application for every college. And it was written on paper. And you sent it in. And then they would send it back. It's amazing, right? You can't even believe that. And you didn't necessarily go with your parents and visit every college campus beforehand. And especially if your parents didn't have the money for everybody to go out to California from Chicago, go to, to Massachusetts or wherever you were applying. So I looked at things. The reason I went to Stanford, they had won the Rose Bowl 2 years in a row back to back. I was a football fanatic.
Yeah.
They had a great engineering program. They played razzle-dazzle football. They were the ones who did those lateral passes and all that kind of crazy stuff. That's the reason I went to Stanford. It was in California. What else can you want?
Makes perfect sense. Yeah.
There you go.
That's why most people go to Stanford. So you go to Stanford. That turns out pretty well. And then you end up going to Cornell here. But even as you're dancing your way through Cornell, you didn't just stay in New York. You actually traveled a little bit. to help people out in the rest of the world. You went to Cambodia, you went to Liberia, Sierra Leone?
Well, so in college, I was also majored in African and African American studies along with Kimmy. And I always wanted to go different places. Remember I told you I like to explore? So anytime I could figure out how to write a grant to go someplace, I would do it. So when I was in medical school, I had an opportunity to go to Cuba. I worked in a Cambodian refugee camp in Thailand. I worked with the flying doctors in East Africa. I mean, if I could figure out a way to go somewhere, I did it, right? And then I had to borrow money or write up a grant, I would do it. And all of that was really a lot about finding out about the world around you. And then I found when I was working in the Cambodian refugee camp in Thailand, people talked about altruism, but it was really, I learned so much about myself. And I learned so much about people that it wasn't about me giving to others, it was about me learning more and feeling comfortable with myself. That's not the reason I went. I mean, it's sort of like I like to do things, I care about people, yet at the same time, we use this term altruism and then we like, I'm really good, right? No, I mean, you learn and you get back from people when you give as well. So that was part of what got me to where I actually went, and I was an area Peace Corps medical officer in Sierra Leone and Liberia after I graduated from from medical school and did my internship and stuff. Then I worked as a area Peace Corps medical officer taking care of State Department personnel and Peace Corps volunteers.
So how did you get from traveling the globe and helping people out in all these different countries to deciding that you wanted to go up above the globe into NASA?
Remember I told you I wanted to go into space and I assumed I'd go into space when I was a little girl? It's just, you know, NASA came and they found out how wonderful I was and they came and they found me. I called down to Johnson Space Flight Center and I said, I'd like to apply to the astronaut program. This is a true story. I called. Once I was.
Just the general number? You could just do that?
I called Johnson Space Flight Center in Houston, Texas, and I said, I'd like to get it, I want to apply to be an astronaut. They said, just a second, we'll transfer you to the astronaut application office. It's a true story. And they sent me an application. It was basically a standard government application. It had some addendums like a physical history, your transcripts. They actually wanted my transcripts from medical school and college. Wow. So it's a good thing I paid off those chemistry bills. So they wanted your transcripts, and then they did some things with it. They did security background clearances. I was in the first class after the Challenger accident, so my application was actually in when the Challenger accident occurred. And then they closed that selection process, they reopened it, and I was selected in 1987.
So that's an amazing story. I think you can do all that online now. It's not a. So I thought maybe the reason
they don't do the medical test online.
They don't.
So I think all my patients got together and told them all the tests I had ever done on them, and then they made sure they ordered those tests on me. So I had things done to me that usually you're not expecting to have done to you till you're in your 70s.
So let's talk about you.
Gonna move on.
We don't have to talk about that. We have to dwell on that. But let's talk about being an astronaut, because that seems like it's pretty cool. What does that even mean? What is the job of being an astronaut? What is that? What do you have to do? What were your duties?
So as an astronaut, you're there to support human spaceflight and be available as a crew member. And when you first come into the astronaut program, you're called an astronaut candidate because you have to do so much work in order to qualify to be a full-fledged astronaut, being assigned to missions. And you're called it ASCANs.
I've been called that myself, but that's not a technical term.
And during that time, you do a lot of training. right? You train all the time. In fact, when you're an astronaut, you're always training, whether you're assigned to a mission or if you're not assigned to a mission. In fact, I actually trained with John Young sometime. John Young was in the second class of astronauts who came in 1961. I remember him from when I was a little girl, and I'm like, oh my God, I'm training with John Young, right? But you're always training, you're always doing things, but you learn to support, and you have to support the other astronauts. So my first job as an astronaut was working as a liaison between Kennedy Space Flight Center and Johnson Space Center and the astronauts. And so I used to follow the shuttle as it was getting ready for launch. So I'd follow the payloads, I followed the shuttle, the orbiter Columbia, and I followed the thermal protection system. So I'm always reporting on all of those kinds of things, watching what's happening. I did the terminal countdown demonstration test. You're doing all of those kinds of things. So you're supporting space flight. I supported human protocol and research committees. I supported different experiments over the years I was there. And then I was assigned to a mission that was called STS-47 Space Lab J, which was a joint mission with the Japanese Space Agency. And it was a laboratory where we carried a laboratory up in the back of the shuttle. And we did lots of different experiments. And I was the first time they flew a position called Science Mission Specialist, which I like to say is like being Mr. Spock on Star Trek, because I was responsible for a lot of the science and being an advocate for the scientists on the ground up in space.
And you know about Mr. Spock because you're a Trekkie. Is that right?
I like Star Trek.
Any Trekkies in the audience?
Anybody like
there?
Star Trek?
Anybody
You don't
like
have to
Star
be a full-fledged Star Trek. Huh?
Yes. Live
long and prosper. That's exactly correct. And we got the hand symbols. Everybody's up doing it. Yep. Yeah, I like Star Trek.
And not only that, but you had a special thing you said when you were communicating with the Earth.
So I like Star Trek. I was fortunate enough to be very good friends with Nichelle Nichols, and that happened because Nichelle was instrumental in getting the first women and minority astronauts selected. She helped recruit them, and she tells a wonderful story about this. I was not one of her recruits, but I was told that I should try to meet her. And one time when I was down at Kennedy Space Flight Center working on the terminal countdown demonstration test, which is almost like a dress rehearsal for a launch, I heard that she was going to be at a Star Trek convention in Orlando. So I decided to go. I was dressed in regular old clothes, and I go up there and I said, I'm an astronaut, and I'd like to meet Nichelle Nichols. I'm at a Star Trek convention. And I said, I'm an astronaut, and I'd like to meet Nichelle Nichols. And they took me to her. And she knew who I was. And we became best friends since. And because she wasn't able to come to my launch because her mother got ill just before it, I opened all my sessions with hailing frequencies are open.
That's awesome.
That's just in recognition.
So that's Lieutenant Uhuru, in case you didn't know.
Lieutenant Uhura.
So you were, besides helping the mission, you were also doing some science experiments while you were up there. Can you tell us a little bit about them? One of them involved frogs.
So we had a number of experiments. This laboratory did life sciences and material sciences experiments. The experiments range from how the human body adapts to weightlessness, where we did echocardiograms to see what happens to your cardiovascular system. We looked at semiconductor materials, how can you make them better, understanding some of the physical properties of matter in microgravity. And we did an experiment that was looking at could you control your own body's adaptation to weightlessness through autogenic feedback training. And we did an experiment that was called frog embryology experiment. It was all about whether or not frog embryos could organize themselves normally in weightlessness. So let's think about this. We evolved down here on a 1G in a gravitational environment, right? So when you stand up, stuff drops and there's an up and a down. Now frog eggs and different amphibian eggs have a light hemisphere and a dark hemisphere. Whenever they're fertilized, the eggs are fertilized, they always rotate with the dark hemisphere pointing up. And if you ever inhibit that rotation, you always get malformations. Okay, so what happens if you're in a place where there's no up and down? You would think you would get malformations, right? But the reality is that we didn't. We took up 4 adult female frogs, and we caused them to ovulate. We stripped the eggs out. We had taken up only the parts of the male frogs that we needed. We fertilized the eggs.
Just keep going.
It is what it is. And we fertilized the eggs, and then we watched to see what happened with the development. We took up a 1G centrifuge so that you could have a control, right? So it's spinning at one time the Earth's gravity, and then we had the other eggs develop in weightlessness. And we got normal organization. So whenever you have a fertilized egg, right, it starts to split into different cells, and then the cells move around the egg ball, and some of them decide to, become an arm, some of them became an eye, some of them become the brain, the legs. So you wondered, is the up and down important to understand, the cells to organize themselves? So weightlessness would cause a problem, but it didn't. The tadpoles were perfectly fine. And so now we have to come back down to the ground and try to understand what's actually happening, that you have to have that up-down axis here on Earth, but it's not necessary in weightlessness.
So did you actually at any given point say, Houston, the tadpoles are okay? You don't have to answer.
No. We used to. We report down what it is. You report down you're very technical about it. You're keeping notes. They're recording notes. You count the number of eggs. You count the number that have hatched in different stages, and then we would preserve some at different stages so that they would be able to look at the development when they came down. And then we had some that lived all the way through, and they actually had progeny here on Earth, right? So they had. We had tadpoles that turned into frogs, and then watched how they developed here on Earth. And they continued to develop normally, which really meant that we have to really understand again what happens to these cells as they're migrating around this ball of eggs. But I basically was giving the information now, and at that point, you're very, very methodical about what you do because you want the information to be transferred accurately.
Right. Well, let me ask the question I think everybody probably wants to ask, and I'm just going to go ahead and say it. When you were up there, could you see your house?
I could not see my house, but the first thing that I saw from space was Chicago. It's an absolute true story. I launched on the middeck, and right after we launched, I had about 2 hours before I was supposed to go to sleep, and there's a lot of work that you have to turn this rocket into a spaceship and into a laboratory. So I'm working on the middeck, and I get a call from our commander, Hoot Gibson. He says, "May, come up." And I look out the window, and there was Chicago. And it was the most incredible thing. It looked just like the map of Chicago when I was a little kid, because sort of the gray outline against the cornfields was like the green of, it looked the same. And I had this huge smile on my face because I remember thinking about that little girl on this, the south side of Chicago, how cool she would think it is. By the time I'm up there, I've done so much work, you're doing so methodical about it. So the big grin comes with imagining how she would think about this, right?
Yeah.
And that was
looking
very
up.
much a part.
In the movie, you'd have the little girl looking up and you looking down. It's an amazing image, amazing thought.
Okay.
So,
but looking up is important. We'll talk about that later.
Yes, it is. We're just going to get to that, actually. So you come back to Earth, and we talked quite a bit about Star Trek. You come back to Earth, and you get a chance to actually be on Star Trek. I
was actually on Star Trek. It happened because a very good friend of mine out of LA, I was in Los Angeles before I joined NASA. A very good friend of mine knew LeVar Burton, and he said, "LeVar, wouldn't it be cool to have Mae on Star Trek?" So I got a call one night saying, "Mae, this is LeVar. Stefan said you'd consider being on Star Trek," and I said, "Yeah." So they wrote me in a role, and So I'm gonna test your Star Trek knowledge now. I was Lieutenant Palmer on an episode called Second Chances. Anybody? There were 2 Rikers. And it was the first time they showed it with 2 Rikers. I was a transport operator, but I was not the one who got him stranded down and slipped. I was trying to help out. But there was 2 Rikers, so they wrote the role in. And so from then on, I've sort of like really been, to a certain extent, a part of the Star Trek family.
That is very cool. So let's go from the Starship Enterprise to the 100-year Starship. Tell us a little bit about that big, ambitious, exciting project.
So 100-Year Starship is an initiative that's aimed at ensuring that we have the capabilities for human interstellar flight within the next 100 years. Notice I said capabilities, not a launch date. It's not like I have trying to build this Starship Enterprise in my back pocket and we're going to launch in 100 years. No, it's the capabilities. And what that means is that we want to make sure that we have an environment and the set of capabilities. If someone wanted to put something together, they could. And it won't be a warp drive engine. I think we're much further out than that. But let's think about what those capabilities are. What's the difference between going to Mars and another star, right? Mars is hard, maybe. I don't think Mars is hard enough. This project was really about pushing our knowledge, our technology, and our human systems in radical ways such that we end up having these leaps in design and capabilities, right? If you look at Mars, you know, we had stuff on Mars when I was a kid. We know Mars' address. We've been there a bunch of times, right? We know how to get there, even if it would take 8 months to get there. We know how to get there. There's some engineering challenges. There's some life science challenges. But we can actually create a roadmap. And the reason I wasn't on Mars had nothing to really do with technology. Some people says it does, but it had to do with really public commitment. But we can't go interstellar. Let me tell you why. Because it's so far, it takes such a long time, and you have to be on your own, and 90% of it is dark, right? When we talk about dark matter, dark energy, we don't actually know what all of that is, but it makes our theories work and our equations work. You know, our closest neighboring star system is called Alpha Centauri. It's 4.2 light years away. It's the distance light travels in 4.2 years. Light travels from the sun to the Earth in 8 minutes, and that's 93 million miles. So how far light travels in 4.2 years is a long ways. That's 25 trillion miles. You know the probe Voyager? I think that's the coolest thing we did as humans, because Voyager is outside of our solar system. It just left our solar system. Voyager has been traveling at over 35,000 miles per hour since 1977. And it just left our solar system. It would take Voyager somewhere from 60,000 years, if it were heading in that direction. It would take it 50 to 60,000 years to get to Alpha Centauri. So it means we had a lot of work to do. We have to go much faster, which means we need completely different energy systems. The shuttle runs on chemical fuels. Most of our launches are on chemical fuels. There is not enough chemical fuel in the entire solar system to get us to another star in a reasonable period of time. So we have to do energy, like we have to do fission, where we break atoms apart. We have to do fusion, what powers the sun, where atoms or molecules go together. Or we have to do antimatter. Each one of them, a step along the way, completely changes our energy system. Imagine if we were able to do a little bit of that. Sustainability. So even if you're able to go 10 to 20% of the speed of light, it's still going to take you 20, 50 years, right? 20 to 50 years. All of a sudden, sustainability becomes a problem. So we're going to have to figure out how to take your food with you, but you can't take enough food for 50 years. You're going to have to learn how to grow it and recycle it along the way. You're not going to be able to stop off for groceries because you're going too fast, right? You're probably not going to come back. So all of the issues around sustainability make a difference. Our microbiome. right? The reason why we're able to digest our food is because of the microbes in our gut. The reason we're able to grow food is because of the microbes in the soil. We have to understand them and take us with them. We live in this really complex ecological system. Right now, you're exchanging bacteria and microbes with your neighbor. Look at the person next to you. Don't worry, don't worry, but you are. But what that means is we have this ability to constantly refresh our microbial systems. When you're in weightlessness, when you're in space, we wouldn't be able to do that. So we have to really understand what it is about it that we have to take with us. You can go on and on. Just think about how you have to fix the Starship, right? Have to have error detection. You have to have very good navigation, which means that you have to have an extraordinary amount of data handling. Because if you just go that much off, you're going that fast, you're going to miss everything you were headed toward. And so there's all these technologies that we need, all this understanding, all this knowledge that we need. And we have to understand people. We have to understand, how do we invest over a long period of time in a technology, in a development, in a system that we may not get the benefit back from the way we measure it right now, right? Where you talk about our return on invested capital, where people say, I'm going to go out and pick this asteroid, I'm going to pull it back, and I'm going to get precious metals out of it. We have to have a different mechanism for valuing this. And then we have to learn and understand human behavior. Because you know somebody's going to get on that vehicle, and when you wake them up, it might be me, because I'm going to go. I'll be in suspended animation. Somebody's going to say, I'm not doing what you told me to do. You know that's going to happen, right? So we have to understand human behavior and how do we learn to interact with each other. It's easy to do it for 1 year, 2 years, but imagine you're on this isolated vehicle for a long period of time. The reason why this is so important is because it mirrors what's happening to us on this starship Earth. It mirrors everything that we need to survive as a species here. That's the reason it's important. Because while we can talk about human behavior with 5,000 people, we don't like talking about human behavior when we talk about the whole Earth. We don't like talking about sustainability when it says I should stop using plastic, when I should have things that recycle. But yet, it's something we fundamentally must do. We must understand that.
All right. And there's an initiative that has grown out of the 100-Year Starship that you're about to launch. Can you talk a little bit about Look Up?
It's called Look Up. It says, what's above us unites us. So one of the things that I've always noted about space is that everybody likes space, right? Even if they don't admit it. I've never run across anyone who didn't say, well, what was it like? Right, because we've all looked up at the stars. We've always wondered what was going on. Again, an African proverb says, no one shows a child the sky. Space is fundamentally part of us. And what we wanted to do is, how do we connect people back to space? Right? Because it can help us connect us. And so what we wanted to do was something that was very simple. Around the world for the exact same 24 hours. It's going to happen in October, and we'll announce the date. But we want people to look up at the sky and take images, text, audio of what they hope, dream, think, feel, fear, plan, offer, need when they look up at the sky. And we will create a globe, or tapestry, a globe that you can spin, and you can see what someone was posting in New Zealand while you were posting in New York at the exact same time. I remember as a little girl looking up and understanding, people on the other side of the planet that I've never met see the same sun I see, that they see the same moon I see. And I remember wondering what they were like, even if I never get to meet them. They may see slightly different constellations, but that tells us we're all on the same planet. And what I do understand from being in space, that when people say save the Earth, they're mistaken. You see, I used to see this thin shimmering layer of blue light that's our atmosphere. And I'd look up at the stars and they were so strong. And yet, people would say, save the earth. They're mistaken. The earth will be here. We might not be. So we got it wrong. We have a right to be in this universe, but it doesn't mean that we have to stay. We give up that right if we overgrow the carrying capacity of this planet for us. And I always tell people, you know, the dinosaurs thought they had it going on too. But it doesn't mean we have to be here. And we have enough knowledge right now to know that we need to make changes. But what holds us back? It's not the technology. It's the understanding that we're earthlings. I was having a conversation with Jill Tarter and LeVar Burton. They're advisors on 100 Year Starship. Jill Tarter was a co-founder of the SETI Institute. She's the person that Jodie Foster's character in Contact was based on, the movie Contact. We were talking about how do we get people to connect? And Jill said, you know, we have to admit that we're earthlings, just like every other plant and animal. And until we admit that we're earthlings, we're not going to solve any of this. So Look Up is about one of those steps to help connect us back to this universe, back to this planet, and back to each other. So I ask you to join us and Look Up, and I'm going to remember to give the website. It's lookupOneSky.org, and we'll have information, and we'll be announcing it very soon.
That's really inspiring. Let's talk about another inspiring project that you're working on, and that's the project that everybody here is invited to see in partnership with Microsoft, the Defying Gravity Women in Space project. What is it like to be turned into a hologram?
Actually, it's uncomfortable. It's not, you know, it's not physically uncomfortable, it's mentally uncomfortable, right? Because, you know, talking to you, I'm used to standing up, I know, and you're getting filmed, but then the holograms, they're taking pictures behind you. You know, and you're like, wait a minute. You're not used to people taking pictures behind you, right? So, and then you know that that's gonna be around for a while. So, but it was very, very neat. I enjoyed being a part of the process and was really honored to be asked to help to bring together these ideas about women in space exploration, because we've been involved in space exploration the whole time, and to be able to help talk about it is important. And why is all of this important? Why is it important who's involved in the sciences? This morning there was a group of young women here called Goals Girls, which was about leadership in science. And the reason why that's important is because of the perspective we bring, right? We will only get our best technology, we will only get our best solutions and policies in this world when we bring the full talent that we have available to us, all the perspectives and expertise and the experiences that we have available. You know, the project that we did called, the proposal for 100 Year Starship that we submitted to DARPA was called An Inclusive, Audacious Journey Transforms Life Here on Earth and Beyond. And that word inclusion probably would not happen if I hadn't been fortunate enough to lead the team that won the proposal. Why inclusion? Inclusion across ethnicity, gender, and geography, but also inclusion across disciplines, right? About finance, about economics, about sustainability, yes, astrophysics, yes, chemistry, yes, life sciences, but making sure that there are people who are involved all around, who tell a better story. Part of the issues we have now is that we don't tell the stories well enough around a lot of things. So that's what we have. And so the reason why I'm excited about this is because it brings us full circle. It helps us think through this. Being involved with great organizations like the Smithsonian, like Microsoft, helps us to really bring this and tell the story in a different way.
Great. I think we might have a clip that everybody can get a little sneak preview of this experience.
When I was a little girl growing up, I was really irritated that there were no women astronauts and there were no people of color. I thought, what about if aliens run into this crew? They're going to think that those are the only people on Earth. I thought it was unreasonable not to have everyone represented. It's critical that Microsoft, NASA, that they're involved in promoting inclusion and diversity. Why? Because who decides which solutions are going to be tested makes a difference in how it affects our world. Today, we're able to get images and ideas around the world much more rapidly. Through mixed reality, building models, being able to share a 3D image of that model to people other places, it helps to foment creativity. We have incredible technology and knowledge, but nothing's going to happen with it to make this world one that's truly shared by all until we figure out how we're connected. Welcome to Defying Gravity, Women in Space. I'm very thrilled to share with you some of the critical contributions women have made to space exploration, especially the shuttle program. So follow me and let's get started. I hope this experience, hearing about the women who helped to make the shuttle possible and space exploration possible, I hope that story sticks. And don't stand around waiting for someone else to give you permission to do something. You go ahead and you make your way. Doesn't matter about gender, ethnicity, or whatever, because we need to use all the talent we have available for us to solve the world's problems and to move us forward.
That is so cool, and you can all go up and do it. It's up on the flight deck. Just look for the giant space shuttle. You can't really miss it. For those of you who've let your subscriptions to Smithsonian Magazine lapse, you're okay. Everybody else, let's get back on the stick. And I think we have time for some questions.
What were some of the problems you experienced when going into space?
So what are some of the issues when going into space that we have to surmount? So multiple of the issues are obviously around adapting to weightlessness. So when your body first gets into weightlessness, it gets a little confused. Because you can stand up and close your eyes and you know which way up and down is because of your inner ear. It can tell you up and down. When you get into weightlessness, your inner ear really doesn't know which way up and down is. Your eyes are looking there and says, there's the top of the shuttle, and it gets confused. And so you get something called space adaptation syndrome. And it lasts for sort of 3 or 4 days. And you just have this really big shift in body fluids as well. So it feels like you've been standing on your head for a few hours, and so that's something that you have to get used to as well, and you urinate out all the extra fluid. Then, so those are challenges to you physiologically, and the challenges for building rocket ships is a whole another piece, but I think the major issues that you have are really about just not getting so giddy when you're looking out the window and saying, hey, and doing your work. But we have no problem doing our work.
Do we have time for another one, or? Okay, let's have another one.
There's one.
Oh, that's good.
How did you translate your medical skills to space?
So how do I translate my medical skills to space? So here's the thing. Whenever you have people involved, you have medicine and life sciences involved. Space exploration is some of the most transdisciplinary work that you'll ever do. You need all the disciplines. So it would almost be like asking the pilots how they translated their piloting skills to space. Because orbital dynamics don't work like it works on the ground. It's not line of sight in the same way. So the interesting thing about medicine for me was in diagnosis and making problems. Medicine, you have to have such a volume of information, right, that you have to commit to memory. That makes a whole bunch of things easy. Now, when I went to medical school, it's changed a little bit, but they used to have something called call, which meant that you stayed up for 24, 36 hours, and you had to function. So that was really good. So your stamina is good. And then you also did things called diagnosis. So somebody comes into you, and they start telling you what the problems are. You have a universe of things that could be going wrong. How do you narrow down and start to understand what you should be thinking about, and how do you test for those problems? So it's really sort of the critical thinking, the problem-solving skills, the stamina, the ability to learn things. But I'll tell you a question that I was asked before that I really liked, which was about how did dance help me? A young woman asked me, about 12 years old, she said, how did dance help me with space? And her class laughed at her. And I think it's one of the best questions I ever had, because dance did help me. First of all, we talked about memorization. When you dance, you have to remember lots of things. Not only your choreography, but the choreography of the people that you're dancing with. And when you're doing a dance production, you don't just learn one dance. You usually have 5 or 6 to 10 dances that you have to remember that has all the other pieces. You have to practice, practice, practice all the time. You have to be able to accept criticism. You have to be able to criticize yourself as well. You have to remember the music, how it coordinates, how it meshes with things. And just the physicality of dancing means you're strong. When you're doing EVAs, you need to know where your body is, what's happening. So all the pieces of knowledge you have, always, you can probably always find a use for it. Sometimes people say, I'm never going to use this. I would bet you that if you think about it, you use every piece of knowledge that you've gained. And to think about it as, oh, this is only for one thing is not really the way it is. We use all our knowledge all the time, and it helps inform us.
That is a perfect place to leave it. Thank you all for coming out here, being part of this. Thank you, Dr. Mae Jemison.
Thank you. I'll get a hug.
Sure, why not?
Thank you very much.
Thank you.
Thank you.